Picture a cold, silent void where stars shiver and darkness reigns eternal. Out there, hidden in the vast cosmic tapestry, lurk terrors beyond human comprehension, phenomena so chilling they defy imagination. We often gaze at the night sky with wonder, but what if I told you that beyond the familiar constellations lie forces capable of unraveling reality itself? This is a universe of infinite horrors where black holes swallow light whole, rogue planets drift without suns, and radiation bursts flash with the power of 1,000,000 suns. And the scariest part, most of these cosmic nightmares remain invisible, unknown, and utterly indifferent to our existence. Today, we invite you to join us on a journey into the deepest, darkest corners of space as we count down the 25 most terrifying phenomena hiding just beyond our atmosphere. Each entry on this list is backed by real science, real mystery, and a real capacity to haunt your dreams. We'll explore things you've never even heard of, celestial monsters and cosmic anomalies that challenge everything we think we know about the universe. From zombie stars that feast on their neighbors to eerie voids where galaxies simply vanish, this is not just a tour of space, it's a descent into the unknown. So find a cozy spot, maybe leave a light on, and prepare to see the cosmos in a whole new light, one that balances awe with a touch of fear, wonder with a shiver down your spine. Whether you're a space enthusiast or just curious about the great beyond, this countdown will change how you look up at the stars forever. Starting with number 1, we have to confront the concept of a rogue black hole. We often picture these cosmic monsters anchored at the center of galaxies, like our own Sagittarius, a star, a predictable if still terrifying force. But what if a black hole broke free from its gravitational chains? That is precisely the nightmare scenario of a rogue black hole. These are not stationary predators. They are nomads of the void, drifting through the interstellar darkness without a single star to call home, completely invisible to our telescopes until they begin to feed. Their origin story is one of cosmic violence. Most form from the cataclysmic collisions of galaxies. When two galaxies merge, their central supermassive black holes eventually spiral toward each other and coalesce. But this merger can sometimes kick a third black hole, perhaps one from a smaller devoured galaxy, out of the new system entirely. This ejection sends it careening into the intergalactic medium at unimaginable speeds, a lone hunter cast adrift. The true terror lies in its stealth. A rogue black hole, by its very nature, gives off no light. It doesn't emit radiation like a pulsar or glow like a star. It is a perfect shadow. We could only potentially detect one by observing the subtle gravitational lensing of distant starlight as it warps the fabric of space around it, or by the frantic, telltale wobble of a star that seems to be orbiting nothing at all. Now consider the horrifying possibility of one of these invisible giants, perhaps dozens of times the mass of our Sun, wandering undetected into our solar system. Its approach would be silent and utterly without warning. Long before we could see any effect on our outer planets, their orbits would begin to subtly shift and stretch. Then, as it drew nearer, the real chaos would begin. The delicate gravitational ballet of our solar system would be thrown into disarray. Planets would be ripped from their orbits, sent crashing into one another, or flung out into the deep freeze of interstellar space. The Sun itself would be tugged and pulled, and Earth's stable orbit, the very thing that allows life to exist, would become a memory. Our planet would either be slingshotted into a frozen exile or pulled inexorably toward the event horizon, to be spaghettified into a stream of atoms. This isn't just science fiction. Astronomers estimate there could be hundreds of millions of these rogues lurking in our galaxy alone, a ghostly population of unseen predators sailing silently through the night. But our own galaxy is not merely a potential victim in this cosmic drama, it is also a predator. We must now turn our attention to the second terrifying phenomenon on our list, a process of unimaginable scale and violence known as galactic cannibalism. This is the fate of galaxies, a slow-motion feast where the largest cosmic structures consume their smaller neighbors in a gravitational dance that lasts for billions of years. The most personal and imminent example of this is happening right now in our own celestial backyard. The Andromeda galaxy, that beautiful, faint smudge of light in our night sky, is not a distant, peaceful neighbor. It is a colossal spiral galaxy, larger than our own Milky Way, and it is on a direct collision course with us, hurtling through space at over 250,000 miles per hour. Andromeda is destined to consume our home galaxy in a cosmic merger of epic proportions. This isn't a sudden, explosive crash. Think of it more as a gradual, inevitable engulfment that will unfold over billions of years. As the two galaxies first begin to interact, their immense gravitational pulls will start to warp and distort each other's shapes. The beautiful spiral arms we recognize will be stretched and torn into long, streaming tails of gas, dust, and stars. The serene structure of both galaxies will dissolve into chaos. During this chaotic gravitational dance, the actual collisions between stars will be incredibly rare due to the vast distances between them. The real terror lies in the forces at play. Stars will not be shattered by impact, but they will be violently uprooted. The gravitational tides will fling countless stars out of their galactic disks, sentencing them to a lonely existence in the cold, dark intergalactic void, forever separated from the light and warmth of their stellar families. Our own solar system could be one of these exiles, thrown from the Milky Way into an endless, sunless journey. Meanwhile, at the hearts of both galaxies, their supermassive black holes will begin a deadly orbital dance of their own. They will spiral toward each other, drawing closer and closer over eons, until they eventually merge in an event so cataclysmic it will send ripples of gravitational waves across the entire universe. The final product of this billion-year feast will be a new, gigantic, and likely featureless elliptical galaxy, nicknamed Milkomda. All evidence of the two beautiful spirals that once were will be erased, consumed in this act of galactic cannibalism. It's a humbling reminder that even the galaxies themselves are not permanent structures, but temporary gatherings in a universe constantly rearranging itself through violent, awe-inspiring acts. Yet even the slow, cosmic violence of galactic cannibalism offers a timescale we can almost comprehend, a drama that unfolds over billions of years. But what if the universe held a threat that could erase everything, every star, every planet, every law of physics in an instant without any warning whatsoever? This brings us to our third and perhaps most conceptually terrifying phenomenon, vacuum decay. This is not a collision or a monster you can see. It is a fundamental flaw in the very fabric of reality, a cosmic trapdoor waiting to be sprung. To understand this, we need to think of the universe not as empty space, but as a field brimming with latent energy. Scientists call this the Higgs field, and it's what gives particles their mass. The prevailing theory suggests our universe exists in a state known as a false vacuum. Imagine this as a valley on a vast cosmic hillside. Our universe is not resting at the very bottom of the hill in the true and most stable state. Instead, we're perched in a higher valley, a local dip that feels stable but is ultimately precarious. For now, the ground beneath our feet seems solid, but it is, in a quantum sense, metastable. The nightmare scenario is that somewhere in the universe, through a random quantum fluctuation, this false vacuum becomes unstable. A tiny bubble of true vacuum could spontaneously form, a region where the Higgs field drops to its absolute lowest, most stable energy state. This event would be a cataclysm unlike any other because it would fundamentally change the rules of the game. The laws of physics as we know them, the constants that allow for atoms, molecules, stars, and life, are a product of our current vacuum state. Inside this new bubble of true vacuum, those laws would be rewritten. Atomic bonds might cease to exist. The very structure of matter could instantly dissolve. This bubble would then expand in all directions at the speed of light. There would be no warning, no flash of light, no sound. One moment, the universe exists as we know it. The next, an expanding sphere of absolute nothingness, or rather, a new state of existence completely incompatible with life, is racing toward us. We would never see it coming. The wave of annihilation would hit our planet, and in that instant, every particle that constitutes you, me, and everything we've ever known would simply cease to be in any recognizable form. It would not be an explosion, it would be an erasure. The entire cosmos would be reset to a blank slate, a new reality with entirely new and likely barren physical laws. The most chilling aspect of vacuum decay is its inevitability if the theory is correct. It could be triggered by a random event a billion light years away a billion years ago, and the sphere of true vacuum could already be on its way, its arrival date completely unknown. Or it could never happen at all. We simply don't know which valley we're truly in. This phenomenon forces us to confront the unsettling idea that the stability of our universe might be an illusion, a temporary and fragile condition that could be revoked at any moment by a random dice roll of quantum mechanics, ending everything in the blink of an eye. Yet even a fundamental rewrite of reality like vacuum decay is, for now, a terrifying abstraction, a quantum possibility hanging over the cosmos. But there is a gravitational mystery that is acting upon us right now, a force so immense it is dragging our entire galaxy and every galaxy near us on a one-way trip to an unknown destination. This is our number 4 terrifying phenomenon, the Great Attractor. We perceive our universe as expanding, with galaxies generally moving away from each other. But when astronomers began to map the precise motions of galaxies in our local neighborhood, they discovered something deeply unsettling. Our Milky Way, along with the entire local group of galaxies including Andromeda, is not moving randomly. We are all being pulled in the same specific direction at a staggering velocity of over 14 million miles per hour. It's as if every galaxy in our corner of the universe is caught in a powerful, invisible current flowing toward a single point in space. Whatever is generating this gravitational pull has the mass of tens of thousands of Milky Ways. It is, for all intents and purposes, a gravitational monster of unbelievable proportions. But here is where the mystery deepens into genuine fear. This colossal anomaly, dubbed the Great Attractor, lies in a region of the sky directly behind the heart of our own galaxy, in the direction of the constellation Centaurus. This area is known to astronomers as the zone of avoidance. It's not a physical barrier, but an observational one. The plane of the Milky Way is dense with gas, dust, and countless stars, creating a thick cosmic fog that completely blocks our view of what lies beyond. For decades, the Great Attractor was a terrifying question mark, an invisible titan pulling us toward it while hiding behind an impenetrable veil. What could possibly be massive enough to command the motion of thousands of galaxies? The most ominous early theories suggested it could be an unfathomably large, concentrated mass of dark matter, or even a gravitational singularity from another universe, a concept that bends the mind. Thankfully, with advanced X-ray and infrared telescopes that can peer through the galactic dust, we've begun to lift the corner of this veil. We now believe the core of the Great Attractor is likely the Norma cluster, a massive conglomeration of galaxies. But the story doesn't end there. In fact, it gets even larger and more humbling. The Norma cluster itself appears to be just the central hub of an even larger structure, the Laniakea supercluster. This is our true cosmic address, a vast filament of over 100,000 galaxies, all gravitationally bound together, and we are merely on the outskirts flowing toward its dense center. So while the immediate terror of a single, unseen monster has subsided, it has been replaced by a profound and awe-inspiring realization. We are not being pulled toward a mysterious predator, but we are simply following the gravitational rivers of the cosmos, flowing toward the largest concentration of mass in our neighborhood. It removes the malevolent intent but underscores our incredible insignificance. our entire galaxy, with its hundreds of billions of stars, is just a single leaf caught in a vast universal current, moving toward a destination we are only beginning to understand on a journey that will take billions of years to complete. While we are being gently pulled by the immense gravity of the Great Attractor, the universe also possesses far more sudden and violent instruments of destruction. If vacuum decay is a silent erasure and galactic cannibalism is a slow-motion feast, then the phenomenon we discuss next is a screaming, instantaneous flash of pure cosmic fury. This brings us to number 5 on our list, gamma-ray bursts. Imagine for a moment the single most powerful, most concentrated release of energy the universe has produced since the Big Bang itself. Now, imagine all of that energy, more energy than our Sun, will emit in its entire 10 billion-year lifetime, focused into a narrow, searing beam and unleashed in a burst that lasts anywhere from a few milliseconds to a few minutes. This is not science fiction, this is a gamma-ray burst, and it is the closest thing to a cosmic death ray that astronomy has ever discovered. For those brief seconds, a single gamma-ray burst can outshine every single star in its entire host galaxy combined, making it the brightest electromagnetic event known to occur in the universe. These cataclysmic events originate from two primary sources, both tied to the death of massive stars. The first, known as long-duration bursts, are born from the collapse of a particular type of star, a hypergiant, a behemoth dozens of times more massive than our Sun. When such a star exhausts its fuel, its core doesn't just collapse into a neutron star, it collapses directly into a black hole. The process is so extreme that it launches twin jets of energy and matter from its poles, moving at over 99.99% the speed of light. If one of those jets is pointed directly at Earth, we witness the spectacle of a long gamma-ray burst. The second type, short-duration bursts, are even more violent in their own way. They are the product of a cosmic collision, when two ultra-dense stellar corpses, neutron stars, spiral into each other and merge, also creating a new black hole and emitting a similar, if shorter, focused scream of gamma radiation. The sheer power involved is almost impossible to comprehend, but the true terror of a gamma-ray burst isn't its brilliance, it's its reach and its effect. If one were to occur within our galaxy, even thousands of light-years away, and if Earth were unfortunate enough to be in the direct line of fire of that narrow beam, the consequences would be an extinction-level event on a scale we can scarcely imagine. The first sign would be a silent flash of light in the upper atmosphere, a light so intense it would literally burn the retina of anyone looking up at the sky. But that would be the least of our problems. The real damage would be done by the radiation itself, which would violently smash into our protective ozone layer and rip it apart. In a matter of seconds, our planet's primary shield against the Sun's harmful ultraviolet radiation would be completely obliterated. The aftermath is the stuff of true nightmares. With the ozone layer gone, the surface of the Earth would be bathed in lethal, mutagenic levels of UV radiation from our own Sun. Phytoplankton in the oceans, the base of the entire marine food web, would be the first to die off. Crops on land would fail, ecosystems would collapse in a cascading catastrophe. It is widely theorized that a gamma-ray burst might have been responsible for the Ordovician mass extinction 450 million years ago, which wiped out over 80% of all marine species. The chilling reality is that it could happen again at any moment. We are essentially living in a cosmic shooting gallery, and a random stellar explosion in a distant part of our galaxy could, without any warning, fire a bullet with our name on it. The light from that explosion would be the first and last warning we would ever get, arriving at the exact same moment as the lethal radiation. It is a reminder that in the vast, violent theater of the cosmos, our survival is often a matter of being in the right place at the right time and looking in the right direction, or more accurately, the wrong one. But if a gamma-ray burst is the universe's sudden, screaming death ray, then the next phenomenon on our list represents a more patient, insidious kind of terror, the horror of something that was dead coming back to life. We are talking about number 6, zombie stars. This isn't a metaphor, it's the chillingly accurate nickname for white dwarf stars that undergo a catastrophic resurrection, detonating in some of the most powerful explosions the cosmos has to offer. To understand a zombie star, you first have to understand its death. A white dwarf is the final, ghostly corpse of a star like our own Sun. After such a star exhausts its nuclear fuel, it doesn't have enough mass to explode. Instead, it goes through a relatively peaceful death, puffing off its outer layers and leaving behind an incredibly dense, Earth-sized core of superheated carbon and oxygen. This core is a white dwarf, a stellar ember that no longer undergoes fusion. It is, for all intents and purposes, a dead star, destined to slowly cool over trillions of years into a cold, black lump of crystallized carbon, a diamond in the dark. It is stable, quiet, and utterly inert. The horror begins when this dead thing is given a chance to live again. A white dwarf rarely exists in perfect isolation. If it has a binary companion, a living star, it can begin to act as a cosmic vampire. Its immense gravity pulls hydrogen gas from its neighbor, siphoning this fresh fuel onto its own surface. With this new material constantly raining down, pressure and heat at the white dwarf's base begin to build to catastrophic levels. Alternatively, in a far more violent scenario, two white dwarfs themselves can eventually spiral into each other and collide. In both cases, the result is the same, a sudden, runaway thermonuclear explosion. The dead star is resurrected in an instant of apocalyptic fury. The entire white dwarf, with a mass comparable to our Sun packed into an object the size of our planet, undergoes total nuclear fusion in a matter of seconds. The energy released is staggering. This event, known as a Type Ia supernova, can briefly outshine its entire host galaxy, releasing more light than billions of stars combined. It is the ultimate stellar destruction, the complete and total annihilation of a star system. For a brief, brilliant moment, the zombie star lives again as the brightest object in the local universe, only to vanish completely, leaving behind nothing but an expanding cloud of glowing stellar debris. What makes these events so uniquely terrifying is their duality. On one hand, they are crucial tools for science, the ultimate cosmic mile markers, because every Type Ia supernova detonates at almost exactly the same critical mass. They all reach nearly the same peak brightness. This predictability allows astronomers to use them as standard candles to measure vast distances across the universe. It was by observing these explosions in distant galaxies that scientists made the shocking discovery that the universe's expansion is accelerating, driven by the mysterious force we call dark energy. So in a way, these zombie stars, through their death, taught us one of the most profound secrets of the cosmos. But on the other hand, this very predictability is also the source of a quiet, looming dread. Our own Sun will one day become a white dwarf, and while it doesn't have a binary partner to threaten it now, the future is measured in billions of years. The gravitational dance of stars within our galaxy is chaotic over such long timescales. It is not entirely impossible that another star could wander too close to our solar system long after the Sun has died, potentially disturbing the peaceful rest of its white dwarf remnant. Or a rogue white dwarf from elsewhere could drift into our vicinity. While the chances are astronomically small, the concept is haunting. The cold, dead cinder of our Sun, reignited by an alien influence, suddenly ending any future existence in our solar system with a flash of light that would be seen across the galaxy. The zombie star is a reminder that in the cosmos, even death is not always permanent, and a peaceful end can be violently revoked by the unforgiving laws of physics. Yet for all the fury of supernova and the silent dread of vacuum decay, the cosmos holds another kind of terror, one not of violent action but of profound and unsettling absence. This brings us to the seventh terrifying phenomenon on our list, a place so empty it has earned the nickname the Great Nothing. We are speaking of the Boötes Void. Imagine, if you will, a sphere of space so vast it could comfortably contain thousands of galaxies like our Milky Way. Now, imagine that within this colossal volume, a region of space 330 million light-years across, there are almost no galaxies at all. This is not a metaphor, it is a real, gaping hole in the cosmic structure, a void so enormous and so empty that its very existence challenges our understanding of how the universe formed. In a typical region of space that size, astronomers would expect to find at least 10,000 galaxies. The Boötes Void contains only a few dozen. It is a desert on a scale that dwarfs comprehension, a place where the average distance between one isolated galaxy and the next is a lonely journey of tens of millions of light-years. The discovery of this void in the 1980s sent shockwaves through the astronomical community. It simply shouldn't exist according to the standard model of cosmology, which posits that matter, both normal and dark, should be distributed in a relatively even, web-like structure across the universe. Finding a void this large was like looking at a vast forest and discovering a single, perfectly circular clearing that stretches to the horizon, devoid of trees. The question immediately arose, what could have possibly caused such a staggering emptiness? Scientists have proposed several theories, each more mind-bending than the last. The leading hypothesis suggests that the Boötes Void is the product of a perfect storm of smaller voids merging over billions of years. As the universe expanded, smaller pockets of nothingness could have gravitationally tugged on one another, eventually coalescing into one gigantic void, much like soap bubbles merging into a single large one. This is the most natural explanation, but it still struggles to account for the sheer, breathtaking scale of the emptiness. This is where the more unsettling theories begin to emerge. Some have speculated that the void could be evidence of something never before observed, a region completely dominated by an unimaginably dense knot of dark matter, whose gravity is so intense that it prevented normal matter from ever coalescing into galaxies in the first place. We cannot see this dark matter, but its gravitational influence would have created a cosmic dead zone. Then there is the most speculative, and for many, the most frightening possibility rooted in the realm of science fiction, yet one that is technically permissible by the laws of physics. This is the concept of a Type 3 civilization on the Kardashev scale. Such a civilization would have mastered energy on a galactic scale, capable of engineering entire star systems. The theory posits that an ancient, hyper-advanced species could have arisen in that region long before our own galaxy even formed. In their insatiable quest for energy or resources, or perhaps in a project of cosmic engineering beyond our understanding, they might have harnessed the power of every single star in every galaxy within that vast volume of space, effectively dimming the entire region to darkness. After consuming the energy of thousands of galaxies, this civilization might have long since transcended, moved on, or vanished, leaving behind only the hollowed-out shell of their once great domain, a galactic-scale ghost town. Whether the cause is a natural fluke of cosmology or something else entirely, the existential dread provoked by the Boötes Void is palpable. It forces us to confront the possibility of true, absolute isolation on a cosmic scale. To be a conscious being on a planet in one of those few, lonely galaxies within the void would be a terrifyingly lonely existence. Peering out into the night sky with a powerful telescope, they would see nothing. In every direction for hundreds of millions of light-years, the sky would be an inky, empty black. There would be no nearby galaxies to dream of visiting, no evidence of other cosmic neighbors. For them, the overwhelming evidence would suggest that their galaxy is utterly alone in a barren universe. It is a haunting reminder that the cosmos may not be a uniformly vibrant tapestry of life and light, but one that also contains pockets of profound and inexplicable silence. While the Boötes Void presents a terrifying vision of cosmic loneliness on a galactic scale, that same profound isolation can also be inflicted upon a single, solitary star. This brings us to our eighth terrifying phenomenon, a class of stellar projectiles known as hypervelocity stars. These are not merely fast-moving stars, they are cosmic bullets, solitary suns hurled out of their home galaxies at such immense speeds that they are destined to travel the unimaginable emptiness between galaxies forever. The story of a hypervelocity star begins with a scene of unimaginable violence, the heart of a galaxy where a supermassive black hole resides. Most stars in this chaotic region orbit the central black hole in a stable, if precarious, dance. But sometimes a binary star system, two stars gravitationally bound to each other, wanders too close to the gravitational monster. The black hole's immense gravity violently disrupts this partnership. In a slingshot maneuver of cosmic proportions, one star is captured into a tight orbit around the black hole, while its companion is flung away at an astonishing velocity, often exceeding 1 million miles per hour. This is not a gentle nudge, it is a gravitational catapult that imparts so much energy to the ejected star that it achieves escape velocity from the entire galaxy itself. The fate of such a star is a form of eternal exile that is difficult to comprehend. Once it crosses the galactic threshold, it embarks on a one-way journey into the intergalactic void. For millions, then billions of years, it will travel through a near-perfect vacuum, a solitary beacon of light in an ocean of absolute darkness. The sky around it would be one of profound emptiness. The familiar band of its home galaxy would slowly recede into a faint smudge of light, eventually vanishing from view entirely. The night sky from a hypothetical planet orbiting this star would be almost completely black, punctuated only by the faint, distant glow of other galaxies impossibly far away. There would be no nearby stellar neighbors, no cosmic landmarks, just an endless, silent journey through the cold. But the terror of hypervelocity stars isn't just about the lonely fate of one star. It's a stark demonstration of the raw, unthinking power that governs the cosmos. The forces at play here are so immense that they can treat a star, a colossal furnace millions of miles across, with the same indifference a child shows when flinging a pebble. A supermassive black hole, without any conscious intent or malice, can effortlessly tear a binary system apart and use its gravity to accelerate a sun to a significant fraction of the speed of light, casting it out into the eternal night. It is a reminder that the universe operates on a scale of power where entire suns are merely pawns in a gravitational game, subject to forces that can create, destroy, or exile them on a whim. These stellar outcasts serve as permanent, speeding monuments to the violence that lies at the heart of every galaxy, a violence that is capable of incredible acts of cosmic expulsion. Just when we thought we had charted the largest structures in the cosmos, from the Laniakea supercluster to the Boötes Void, astronomers stumbled upon an anomaly so strange it threatened to rewrite our entire understanding of the universe's boundaries. This is our ninth terrifying phenomenon, dark flow. Imagine the entire observable universe, hundreds of billions of galaxies, all moving in a grand, expanding dance since the Big Bang. Now picture a mysterious, unseen current pulling thousands of these galaxy clusters in one specific direction, like leaves caught in a cosmic river flowing toward a waterfall we cannot see. This isn't just movement, it's a coordinated bulk flow of immense structures toward something outside. The discovery of dark flow came from studying the cosmic microwave background, the faint afterglow of the Big Bang that permeates all of space. This radiation creates a universal frame of reference, much like a grid against which all motion can be measured. When scientists meticulously mapped the motion of enormous galaxy clusters by observing how this ancient light was slightly distorted as it passed through them, an effect known as the kinetic Sunyaev-Zeldovich effect, they found something that defied all logic. These clusters, some containing thousands of galaxies, were all streaming at velocities of over 2 million miles per hour toward a single point in the sky between the constellations of Centaurus and Vela. This motion was separate from and far faster than the universe's overall expansion. It was as if these titanic structures were being tugged by a gravitational force of impossible magnitude, a force originating from beyond the edge of everything we can see. The immediate and most unsettling implication is that the gravitational source of this dark flow must lie outside our observable universe. According to the standard model of cosmology, the mass and energy within our visible cosmos should dictate all large-scale motion. Nothing within our universe is massive enough or coordinated enough to be pulling matter in this way. This leaves only one truly paradigm-shattering possibility. The pull is coming from something in the great, unobservable beyond. The most compelling theory points toward the multiverse. If our universe is just one bubble in a vast foam of countless other universes, then one of these neighboring universes could be exerting a gravitational influence on our own. Think of it as a colossal, invisible universe lying just past the horizon of our own, its immense mass creating a gravitational tide that tugs on the fabric of our reality. We cannot see it, we cannot touch it, but we can feel its pull on the largest structures we can observe. Another, even more speculative theory suggests the source could be a pre-Big Bang structure, a remnant of a previous cosmic cycle or a flaw in the very fabric of space-time from before our universe began. Whatever the cause, the existence of dark flow introduces a profound and humbling terror. It suggests that our entire cosmos, everything we know and will ever know, might not be a closed, independent system. We could be a small province in a much larger, multidimensional empire, subject to laws and forces from realms we cannot access or comprehend. Our universe might be floating in a greater ocean, and we are only now detecting the current that has been carrying us along for billions of years toward a destination we can never hope to see. It is the ultimate cosmic conspiracy, the feeling that we are not the masters of our own fate, but are instead being pulled by invisible strings from a stage hidden behind the curtain of reality. All of these cosmic horrors, from dark flow pulling at the universe itself to hypervelocity stars cast into the void, pale in comparison to a mystery that is literally all around us, a silence so profound it screams. This brings us to our 10th terrifying phenomenon, a puzzle that has haunted scientists and philosophers for decades, the Fermi paradox. The universe is ancient beyond comprehension, nearly 14 billion years old. It is vast beyond imagining, containing hundreds of billions of galaxies, each with hundreds of billions of stars. The raw ingredients for life, water, organic compounds, are scattered everywhere from the clouds of gas between stars to the surfaces of distant moons. The math is overwhelmingly on the side of life. By any reasonable statistical calculation, the galaxy should be teeming with civilizations. The night sky, we assume, should be a bustling metropolis of light, filled with the radio chatter of a million different species. And yet, when we listen, we hear nothing but a deafening, empty silence. Where is everybody? This simple question, asked by physicist Enrico Fermi over lunch one day, has grown into one of the most profound and frightening mysteries in all of science. One of the most prominent and deeply unsettling answers to this paradox is known as the Great Filter theory. This idea suggests that the development of intelligent, spacefaring life requires passing through a series of evolutionary and technological steps, and that one of these steps presents a barrier so difficult that it filters out almost every civilization that attempts it. The terrifying part is not knowing where this filter lies. Is it behind us, perhaps the emergence of life itself, or the jump from single-celled to complex multicellular organisms is astronomically rare? If that's the case, we are a miraculous fluke alone in a sterile cosmos, but the more frightening possibility is that the great filter lies ahead of us. This theory posits that advanced technological civilizations inevitably discover the means of their own destruction and are unable to avoid it. perhaps every species that discovers nuclear power inevitably turns it upon itself. Maybe the path of technological progress always leads to the creation of a superintelligence that sees its creators as a threat, or perhaps they all inevitably create a particle accelerator experiment that accidentally unravels the fabric of space-time. If the Great Filter is in our future, it means that the eerie silence we hear is the sound of countless graveyards, a universe full of species that reached our level of development and then suddenly vanished. Our continued existence may not be a sign of our success, but merely a countdown to a preordained failure. An even more chilling solution to the silence is the dark forest hypothesis, a concept drawn from science fiction but rooted in grim cosmic logic. This theory treats the entire universe like a dark, ancient forest. Every civilization is a hunter, armed and hidden, moving through the trees with extreme caution. Why? Because in a forest where you cannot tell friend from foe, the only rational strategy for survival is to stay completely silent and to shoot anything that makes a sound before it can shoot you. The fundamental assumption is that the two primary goals of any species are survival and the acquisition of resources. Any other civilization you encounter is a potential competitor for those finite resources, and worse, you can never know their true intentions. The gap between stars makes communication slow and trust impossible to build. A civilization that announces its presence is not being friendly, it is being recklessly naive. The safest, most logical course of action is to remain utterly hidden while simultaneously scanning the heavens for any sign of another civilization. And if you do detect one, especially one less advanced than you, the only sensible move is to immediately and quietly eliminate it before it has a chance to become a threat. In this terrifying model of the cosmos, the silence isn't a mystery, it's a survival tactic. The galaxy isn't empty, it's full of civilizations that have perfected the art of staying quiet. They are all listening, and they are all ready to strike at the first sign of another. We might not hear them because they are too smart to reveal themselves, and our own attempts at communication, like the signals from our radios and televisions leaking into space, could be the very thing that paints a target on our planet for a civilization that has been hiding in the shadows for millions of years. Other explanations, while less overtly hostile, are no less unsettling. Perhaps we are simply too early or too late to the party. The universe may have gone through cycles of habitability, with periods where cosmic radiation or frequent gamma-ray bursts made complex life impossible. We could be among the very first civilizations to emerge in a universe that is only now becoming calm enough for life to flourish. Or conversely, we might be one of the last, arriving long after the great galactic empires have risen, fallen, and vanished into dust. Another possibility is that space is just too big. The distances between stars are so immense that even for an advanced civilization, interstellar travel might be a practical impossibility, forever isolating intelligent species on their own world. Or perhaps intelligence itself is not an evolutionary advantage in the long run. Maybe every technological civilization eventually creates a virtual reality so perfect and engaging that they simply lose all interest in the external, physical universe, retreating into simulated paradises and abandoning the stars. Each of these answers to the Fermi paradox carries its own unique brand of existential dread, forcing us to confront the possibility that we are either tragically alone, doomed to self-destruct, living in a universe of hidden predators, or simply irrelevant in a cosmos that doesn't care about consciousness. The silence is not empty, it is full of terrifying answers. We just have to be brave enough to listen to what it is telling us. But perhaps one of the most immediate and personal threats comes not from the distant cosmos, but from the very star that gives us life. We take the sun's regularity for granted, a reliable clock in the sky that rises and sets with comforting predictability. But our sun has a temper, and its occasional outbursts remind us that we are orbiting a massive, unstable fusion reactor. This brings us to our 11th terrifying phenomenon, solar superflares. The Sun is not a placid ball of fire. It is a churning, dynamic sphere of superheated plasma, and its surface is regularly marred by explosions. The most common of these are solar flares, sudden flashes of intense high-energy radiation, and coronal mass ejections, which are massive bubbles of plasma and magnetic field hurled into space. We experience minor versions of these events regularly, and they usually result in nothing more than beautiful auroras near the poles. But history shows us that the Sun is capable of far, far worse. In late August and early September 1859, the skies over Earth erupted in a light show of unprecedented scale. Auroras, typically confined to the polar regions, were seen as far south as the Caribbean and Colombia. People in the northeastern United States could read newspapers by the brilliant crimson and green light of the midnight sky. But this breathtaking beauty was the side effect of a cosmic catastrophe. The cause was what we now call the Carrington event, named after the astronomer Richard Carrington, who witnessed the massive solar flare that triggered it. A coronal mass ejection of unbelievable power had traveled from the Sun to Earth in just 17 hours, a journey that normally takes days. When it hit our planet's magnetic field, it induced powerful electrical currents in the ground itself. In 1859, the world's technological landscape was primitive. The telegraph was the pinnacle of electronics, yet the effects were dramatic and terrifying. Telegraph systems across Europe and North America spectacularly failed. Operators received severe electric shocks. Telegraph pylons threw sparks. Some machines continued to send and receive messages even after being disconnected from their power sources, running entirely on the atmospheric currents generated by the storm. The world's frail technology was completely overwhelmed by the Sun's fury. Now, fast forward to today. Our civilization is utterly, inseparably dependent on a vast and incredibly delicate global network of electronics. Our entire way of life is built upon a foundation of power grids, satellite communications, and digital infrastructure. A Carrington-level event striking Earth today would not be a fascinating historical anecdote. It would be an unprecedented global catastrophe that would send us back to the pre-industrial age overnight. The immense geomagnetically induced currents would flood into our power grid, overloading and melting the massive transformers that are the heart of our electrical systems. These transformers are not spare parts you can pick up at a local store. They are custom-built, multi-million-dollar machines that take months or even years to manufacture and replace. A simultaneous loss of hundreds of these critical nodes would cause a cascading failure of the entire grid, leading to a blackout that could encompass continents and last for years, not days or weeks. The domino effect would be swift and devastating. With no power, water treatment and pumping stations would fail within days. Financial systems, which are entirely digital, would cease to exist, wiping out savings and collapsing the global economy. Refrigeration would stop, leading to the rapid spoilage of food and medicine. Fuel pipelines would shut down, halting transportation. Satellites, which we rely on for everything from GPS and weather forecasting to global communications and banking transactions, would be fried by the radiation, their delicate electronics irreparably damaged. We would be plunged into a literal and figurative darkness, cut off from each other and from the information that sustains modern society. The societal collapse that would follow is almost too grim to contemplate. And here is the most chilling part. The Carrington event is not the worst the Sun can do. Geological evidence from ice cores suggests that our Sun has produced solar storms orders of magnitude more powerful than the one in 1859. In fact, a study of radioactive isotopes in tree rings and ice cores points to an event around 14,300 years ago that was so powerful, it makes the Carrington event look like a mere spark. We are living on a planet that orbits a star with a proven capacity for apocalyptic violence, and we have built a glass house directly in the line of fire. Unlike a gamma ray burst from a distant star, a solar superflare is not a matter of if, but when. Scientists estimate there is roughly a 12% chance of an event on the scale of the Carrington event occurring within the next decade. We are essentially playing a game of Russian roulette with our own sun, and the stakes are the entirety of our technological civilization. While we look to the stars with dreams of exploration, a threat of our own making silently accumulates in the void just beyond our atmosphere, a danger that could slam the door on space for centuries to come. This is the nightmare scenario known as the Kessler syndrome, a potential chain reaction of destruction that could transform the space around Earth into an impenetrable, high-speed shrapnel field, effectively placing our planet under a permanent and inescapable quarantine. The stage for this disaster is already set. Since the launch of Sputnik in 1957, we have been littering the orbital pathways around our planet with abandon. Today, that region is a junkyard of epic proportions. It's not just the thousands of active satellites, it's everything we've left behind. Decommissioned satellites, spent rocket boosters, tools dropped by astronauts during spacewalks, flecks of paint, and even frozen coolant. All of it is caught in a relentless orbital dance. The European Space Agency estimates there are over 130 million pieces of space debris larger than a millimeter, and more than 36,000 objects larger than a softball being actively tracked. Each one of these objects is a potential bullet traveling at orbital velocities exceeding 17,000 miles per hour. At that speed, even a tiny paint chip carries the kinetic energy of a bowling ball dropped from a multi-story building. A collision with a fragment the size of a marble would be equivalent to a grenade exploding, capable of completely obliterating a satellite or piercing the hull of the International Space Station. The true terror of Kessler syndrome is not a single collision, but the domino effect it could trigger. Imagine one piece of a defunct satellite, itself no bigger than a fist, colliding with an old rocket body. That impact wouldn't just create two pieces of debris, it would shatter both objects into thousands of new, smaller projectiles. Each of those new fragments now has its own chaotic orbit, dramatically increasing the probability of further collisions. Those secondary impacts would then create even more debris, which leads to more collisions, and so on. This cascading chain reaction could, in a worst-case scenario, become unstoppable. Within a matter of years or even months, certain orbital highways, particularly the incredibly useful low Earth orbit, could become so densely packed with fast-moving junk that any object we put there would be almost instantly pulverized. It would be like trying to sail a ship through a hurricane of bullets. The consequences of such an event are almost too catastrophic to fathom. First, our global technological society would suffer a near instantaneous collapse. The vast network of satellites we depend on for GPS navigation, worldwide communications, weather forecasting, agricultural monitoring, and global finance would be systematically annihilated. We would lose our eyes in the sky, our voices across the oceans, and our ability to predict catastrophic storms. The economic and societal chaos would be unprecedented. But the deeper, more profound loss would be to our future. The International Space Station, a symbol of international cooperation and a platform for incredible scientific discovery, would be immediately evacuated and then slowly, inevitably chewed apart. Any hope of building a replacement station or a gateway to the Moon and Mars would vanish. Crewed spaceflight would become impossible. Uncrewed scientific probes like the Hubble Space Telescope would be destroyed. We would be trapped. The shimmering shell of debris encircling our planet would become a prison of our own creation, a constant, visible reminder in the night sky of our short-sightedness, as the glittering fragments of our ambition reflect the sun's light back at us. The dream of becoming a multi-planetary species, of ensuring the long-term survival of humanity by expanding beyond our cradle, would die before it ever truly began. The most frightening aspect of the Kessler syndrome is that we are already flirting with this potential catastrophe. several major events have given us a terrifying preview. In 2007, China intentionally destroyed one of its own weather satellites in an anti-satellite missile test, single-handedly creating over 3,000 trackable pieces of debris, a cloud that will remain a hazard for decades. Just 2 years later, in 2009, a defunct Russian Cosmos satellite collided with an operational American Iridium communications satellite. That accidental crash generated another 2,000-plus pieces of large debris, further polluting a valuable orbital band. Each of these events was a stark warning, a shot across the bow showing us how quickly we can make a critical region of space more dangerous. Avoiding this fate is one of the greatest engineering and diplomatic challenges of our time. It will require a global effort to stop the bleeding by designing satellites that can deorbit themselves at the end of their lives and to start cleaning up the mess we've already made. Proposed solutions range from giant nets and robotic arms to capture large debris, to ground-based lasers that could nudge smaller pieces into safer trajectories. But these technologies are in their infancy, and the political will and international cooperation needed to deploy them on a massive scale is lacking. The Kessler syndrome is a slow-motion disaster we have the power to prevent, but unless we act with urgency and unity, the final frontier may close before we ever truly get to explore it. Yet for all the orbital debris we have created ourselves, the cosmos has its own natural version of a demolition derby, one that operates on a scale of power that makes our solar flares and space junk seem utterly trivial. If you thought colliding galaxies or rogue black holes were the epitome of cosmic violence, prepare yourself for number 13, neutron-star mergers. This is the ultimate death spiral, a cataclysmic event where two of the universe's most extreme objects engage in a final, fatal dance that literally shakes the fabric of the cosmos and forges the very elements that make our existence possible. To understand the sheer terror of this event, you must first grasp what a neutron star is. Imagine taking a star over 1.4 times the mass of our entire Sun and crushing it down into a perfect sphere no wider than a city like Chicago or London. The result is an object of almost incomprehensible density. A single sugar cube-sized piece of a neutron star would weigh as much as Mount Everest. Its surface gravity is so intense that if you were to drop a marshmallow onto it from just a meter away, it would impact with the force of 1,000 hydrogen bombs. These objects are the crystalline cores left behind after a supernova explosion, and they are so perfectly dense that they are essentially giant atomic nuclei, made almost entirely of neutrons. They spin at dizzying rates, often hundreds of times per second, and possess magnetic fields so powerful they could wipe the information from every credit card on Earth from halfway across the galaxy. Now picture two of these unimaginable objects locked in a binary orbit. As they circle each other, they lose energy in the form of gravitational waves, those ripples in space-time first predicted by Einstein. This loss of energy causes their orbits to slowly decay over millions of years, drawing them inexorably closer. In the final moments, their dance accelerates from a slow waltz to a frantic, screaming crescendo. They orbit each other thousands of times per second, moving at a significant fraction of the speed of light. The gravitational forces at play become so extreme that they begin to rip each other apart even before they touch. Tidal forces pull long, superheated streams of neutron-rich material from their surfaces, creating a swirling, radioactive vortex around the pair. The final collision is not a simple impact. It is a true merger. The two city-sized orbs smash together and fuse into a single, hypermassive object. For a brief moment, this new object might form a neutron star so massive it briefly defies physics, only to almost instantly collapse under its own weight into a black hole. The energy released in this event is beyond staggering. For a few seconds, the merger outshines every star in the observable universe combined, erupting in a flash of gamma rays, a short gamma ray burst. But the true spectacle is in the aftermath. The violent collision acts as the universe's ultimate forge. The incredible tempest of neutrons flooding the environment allows atomic nuclei to capture them at an astonishing rate, rapidly building heavier and heavier elements in a process known as rapid neutron capture, or the R process. It is in these few seconds of apocalyptic violence that the universe creates most of its gold, platinum, and other heavy elements. The collision blasts these newly forged precious metals out into space in a magnificent, expanding cloud of glowing debris known as a kilonova. Every gold ring on your finger, every platinum wedding band, was almost certainly born in the heart of a cataclysm like this, billions of years ago, before being incorporated into the nebula that formed our solar system. We are literally walking stardust, but the jewelry we prize is something far more violent. It is the fallout from a cosmic collision of unimaginable ferocity. The first time humanity ever directly observed one of these events was in August of 2017, when gravitational wave observatories detected the ripples from a merger labeled GW170817. Just seconds later, telescopes around the world and in space swiveled to the same patch of sky to witness the resulting kilonova flare in the galaxy NGC 4993, 130 million light-years away. That single observation confirmed decades of theory and opened a new era of multi-messenger astronomy, where we can both feel the space-time shake and see the light show from the same event. It was a breathtaking demonstration of both the destructive power and the creative beauty of the universe, a reminder that from the most violent ends can come the very materials that allow for new beginnings. Yet amid the chaotic violence of colliding stars and the silent dread of the Fermi paradox, there exists a single, tantalizing piece of evidence that suggests we might not be alone after all, a signal from the void so perfect it has never been explained, and so fleeting it has become a permanent cosmic mystery. This is the story of the WOW signal, a 72-second burst of radio noise that remains the most compelling and most terrifying candidate for an extraterrestrial transmission ever discovered. The scene was a radio telescope in Delaware, Ohio, known as the Big Ear. It was a sweltering August evening in 1977, and the telescope was methodically scanning the sky as part of Ohio State University's long-running search for extraterrestrial intelligence, or SETI, project. The system was automated, printing out strings of alphanumeric characters on wide, fan-fold paper to denote the strength of any signals it received. Most of the printouts were a boring sea of zeros and ones, representing the background static of the universe. But just after 10:16 p.m., something extraordinary happened. The telescope's twin beams swept across a patch of sky in the constellation Sagittarius, and the recorder suddenly went wild. The signal was so intense that it maxed out the equipment's scale. It was a narrow-band transmission, precisely at the magic frequency of 1420 MHz, a wavelength that is naturally protected from interference because it is generated by hydrogen, the most common element in the universe. Scientists had long theorized that any intelligent species trying to get noticed would use this universal channel, a cosmic hailing frequency. This signal was exactly what they had been waiting for. A few days later, a young volunteer named Jerry Amon was poring over the stacks of computer printouts when his eyes fell on the string of characters from that night, 6EQUJ5. He was so stunned he circled the sequence in red pen and wrote a single, heartfelt word next to it: WOW. The name stuck. The signal was everything they could have hoped for. It had the exact predicted frequency, it was extremely powerful, and it exhibited the telltale rise and fall in intensity that matched the telescope's rotation as it locked onto and then passed over the source. It was a perfect bullseye. The elation was immediate but short-lived. The very next day, and every day for decades after, astronomers pointed every available telescope, from radio dishes to optical scopes, back at that exact same spot. They listened for thousands of hours, they scanned again and again, but the signal never returned. It was a one-time event, a cosmic whisper heard once and then swallowed by an eternal silence. This singular nature is what transforms the wow signal from a fascinating anomaly into a deeply unsettling mystery. If it wasn't aliens, what could possibly explain it? Natural cosmic objects like pulsars or quasars emit radio waves, but they are either repetitive or broad spectrum. They don't transmit a clean, narrow-band signal on that specific frequency and then vanish forever. A passing comet was proposed as an explanation decades later, but the specific comet wasn't even in that part of the sky at the time. Human-made interference from a satellite or aircraft seems the most likely culprit, yet a thorough investigation has never found a match. No known military, commercial, or scientific transmission from that era fits the profile. It came from nowhere and went back to nowhere. This leaves us with the profound and chilling possibility that we did indeed intercept something artificial. But if it was a message, its brevity is its most ominous quality. What kind of message lasts only 72 seconds? It could have been a lighthouse-like beacon, a simple "we are here" signal that we happen to catch during a single, fleeting sweep of its beam across our solar system. But it could also be something far more grim. Perhaps it was a distress call, the final, automated scream of a dying civilization, a ship or a world being destroyed, its transmission cutting off abruptly as its source was vaporized. Maybe it was the cosmic equivalent of a single, unreadable SOS tapped out by a sailor trapped in a sinking ship, a message we received but were too primitive and too slow to understand or answer. The wow signal stands as a monument to both our deepest hopes and our most primal fears in the search for cosmic company. It is the ultimate teaser trailer for a movie we may never get to see. It proves that the cosmos is capable of producing a signal that is, for all intents and purposes, indistinguishable from an intelligent greeting. And yet, its refusal to ever repeat itself leaves us in a state of perpetual uncertainty. It is the universe's greatest unsolved mystery, a single, cryptic line of text from a conversation we are not yet privy to. It is the phone ringing once in a dark, empty house, and by the time you pick up the receiver, there's nothing on the other end but a dial tone and the terrifying question of who or what was on the line. But if the wow signal represents a fleeting moment of possible contact, a whisper on a specific frequency, then the next phenomenon is a constant, overwhelming presence that permeates every inch of the cosmos, a ghost that holds the universe together yet refuses to be seen. We have arrived at number 15, a substance so fundamental to existence yet so utterly mysterious it redefines the word elusive: dark matter halos. For centuries, we believed that the universe was made of the stuff we could see: stars, gas, planets, and dust. But in the 1930s, a brilliant and stubborn astronomer named Fritz Zwicky was studying the Coma Cluster, a massive group of galaxies, when he noticed something that defied all logic. The individual galaxies within the cluster were moving far too quickly. The combined gravitational pull of all the visible stars and gas in the cluster was simply not enough to hold them together. According to the laws of physics, the cluster should have flown apart long ago. Yet there it was, stable. Zwicky concluded there must be some form of dunkle materie, or dark matter, providing the extra gravity, an invisible glue holding the cosmic structure intact. For decades, his idea was largely ignored, dismissed as a fringe theory. But as technology improved, the evidence became undeniable. We now know that dark matter is not a minor component of the universe, it is the dominant one. All the stars, planets, nebulae, and every single atom that makes up you and me, everything we call normal matter, comprises a pitifully small 5% of the cosmos. Dark matter makes up a staggering 25%. It is the universe's hidden architecture, its invisible skeleton, and its primary manifestation is in the form of vast spherical halos that envelop every galaxy, including our own Milky Way. Picture our beautiful spiral galaxy not as an island of stars, but as a glittering city built within a massive, invisible snow globe. The stars, gas, and dust we see are just the lights of the city, concentrated in the bright downtown core and the sparkling suburban disk. But the true bulk of the snow globe, the thing that gives it its shape and holds the entire city together, is the clear, invisible liquid filling it, the dark matter halo. This halo is immense, extending hundreds of thousands of light years beyond the visible edge of the galaxy, and it contains over 5 times more mass than all the visible stars and gas combined. The true terror of dark matter is not that it exists, but what it implies about the limits of our perception and the very nature of reality. This is not simply black dust clouds or cold gas that we haven't found yet. We know what it isn't. It doesn't emit, absorb, or reflect any form of light or electromagnetic radiation. It is completely transparent and, for all intents and purposes, invisible across the entire spectrum. It doesn't interact with normal matter in any way except through gravity. This means that right now, as you watch this, a hurricane of dark matter is passing through you, your home, and the Earth itself. Trillions of these hypothetical particles, likely what physicists call WIMP, or weakly interacting massive particles, are streaming through your body every second without a single collision. You cannot feel it, you cannot detect it, and no instrument we have ever built can directly see it. It is a phantom mass, a ghost that we only know is there because we can see the gravitational footprints it leaves behind. The way it bends the light from distant galaxies in a process called gravitational lensing, and the way it dictates the rotation speeds of stars within galaxies. This leads us to the most unsettling implication. We are living in a universe dominated by something we cannot sense, cannot study directly, and do not understand. Our entire perception of reality is based on the 5% that lights up. We are like goldfish in a bowl, blissfully unaware of the ocean outside because we can only perceive the water we swim in. The rules of our existence are written by a substance that operates by rules we are only beginning to guess at. What's more, the sheer amount of it suggests that our standard model of particle physics, the most successful theory we have for how the universe works, is woefully incomplete. It does not account for this hidden majority. Dark matter is the single greatest unsolved problem in physics, a constant, humbling reminder that for all our intelligence and ingenuity, the universe is still keeping its biggest secrets close. It is the ultimate cosmic conspiracy happening all around us, holding our very galaxy together, and we are completely unaware of its silent, pervasive flow. But if the silent, pervasive flow of dark matter is the universe's hidden architecture, then the next phenomenon represents its lost children, cast out into the cold and left to wander the eternal night. We now turn to number 16, a class of celestial object that embodies true cosmic loneliness, rogue planets. For centuries, our understanding of planets was simple. They are worlds that orbit a star, basking in its light and warmth. But this comforting definition is tragically incomplete. The process of planetary formation is a violent and chaotic ballet, and not every world finds a permanent home. Gravitational interactions between young, massive planets can be so fierce that one of them is often flung out of its nascent solar system entirely, sent careening into the blackness of interstellar space. These are the rogue planets, orphan worlds with no sun to call their own. They are the cosmic equivalent of a ship cut loose from its moorings, set adrift on an ocean with no shore in sight. Current estimates suggest these lonely wanderers are not rare anomalies. They are astonishingly common. Some astrophysicists believe there could be billions, even trillions, of them roaming the dark between the stars in our galaxy alone, far outnumbering the stars themselves. The immediate image is one of a frozen, airless hell. A planet ejected from its solar system would rapidly lose any residual heat from its formation. Surface temperatures would plummet to just a few degrees above absolute zero, plunging into a deep freeze that makes the ice giant Neptune look balmy. Any atmosphere it once possessed would freeze solid, falling to the surface as a blanket of snow, leaving the world exposed to the vacuum of space and the full barrage of cosmic radiation. It is a death sentence for any life as we know it on the surface, a perpetual, silent tomb drifting through an endless winter. However, the true terror and fascination of rogue planets lies in a tantalizing possibility buried beneath this frozen exterior. Take, for example, a gas giant like Jupiter, or a large, rocky world several times the mass of Earth. Such a massive planet could retain a thick, insulating hydrogen atmosphere that acts like a gigantic thermal blanket, slowing the loss of its internal heat for billions of years. More intriguingly, a water-rich world, an ocean planet, might not freeze solid all the way through. The immense pressure from the overlying ice could keep a global ocean in a liquid state deep beneath a frozen crust, insulated from the frigid vacuum above. This creates the possibility of a subsurface ocean, much like the ones we believe exist on moons like Europa and Enceladus, but on a planet scale. Around a star, such an ocean is a promising habitat for life. Adrift in the dark, it becomes a self-contained, isolated biosphere, a sealed capsule of potential biology traveling through the void. The energy for life wouldn't come from sunlight, but from the planet's own internal heat, through hydrothermal vents on the ocean floor, chemosynthesis instead of photosynthesis. An entire alien ecosystem could thrive in absolute darkness, utterly unaware of the concept of a sky or a sun, living and dying in a warm, pressurized pocket buried under miles of ice on a world that is going nowhere. This leads to one of the most unsettling concepts in astrobiology, the idea of panspermia, the natural transfer of life between worlds. A rogue planet with such a hidden ocean could, in theory, act as a lifeboat for microorganisms. If it were to pass through a forming planetary system, perhaps even our own solar system, the gravitational encounter could potentially transfer material. More terrifyingly, if such a life-bearing rogue world were to collide with a habitable planet in another system, it could literally seed that world with its cargo of alien biology. Life might not always spread gently on the solar winds. It could arrive via a catastrophic impact from a silent, frozen bullet from the depths of interstellar space. The final chilling aspect of these dark wanderers is their stealth. A rogue planet emits no light of its own and reflects no starlight. It is a virtually black object against a black background. We could only detect one if it passed directly in front of a distant star, causing a momentary dimming, or if it were still young and warm enough to glow faintly in the infrared. The vast majority are completely invisible to us. This means one could be passing through our outer solar system right now, in the realm of the Oort cloud, and we would have no idea. Its gravitational influence would be minuscule until it was very close, a subtle tug on the orbits of distant comets that we might not notice for centuries. The thought that our solar system, which feels so orderly and predictable, could be silently penetrated by an unseen, world-sized intruder is a profound reminder of the dark and dynamic nature of our galactic neighborhood. These orphan worlds are the ghosts of the cosmos, silent testaments to the violent processes of creation, and potential arcs carrying the secret of life through the freezing darkness between the stars. Yet for all the chaos of rogue planets and the subtle influence of dark matter, these phenomena operate on timescales and scales of power we can, with effort, comprehend. But the ultimate fate of the entire cosmos may be governed by a force so alien and powerful that its conclusion is not a slow fade to black, but a violent, explosive end to reality itself. This is the 17th terrifying phenomenon on our list, a cosmological nightmare known as the Big Rip. For most of scientific history, we believed the universe's expansion was slowing down, gradually coasting after the initial momentum of the Big Bang. That all changed in the late 1990s when two separate teams of astronomers made a Nobel Prize-winning discovery that shocked the world. By observing distant supernovae, they found that not only is the universe expanding, but that expansion is accelerating. Something is actively forcing space itself to stretch apart at a faster and faster rate. That something is the mysterious force we call dark energy. Think of it as a kind of anti-gravity, a repulsive force woven into the very fabric of the vacuum of space. While gravity pulls matter together, dark energy pushes it apart. And as the universe expands and creates more space, more dark energy appears, creating a runaway feedback loop of acceleration. For billions of years, the cosmic tug-of-war between the inward pull of gravity and the outward push of dark energy has been relatively balanced on the largest scales. This is why galaxies and galaxy clusters have held themselves together. But what if dark energy isn't just a constant force? The most frightening model for its behavior is known as phantom dark energy. In this scenario, the strength of dark energy isn't constant. It actually increases over time. Its density grows as the universe expands, becoming more and more powerful. If this model is correct, and some measurements hint that it might be, then the fate of the universe is not a slow cooling, but a catastrophic shredding. The Big Rip is the ultimate expression of this dark energy domination. It begins on the largest scales, billions of years from now. The first casualties will be the largest structures in the universe. The gravitational glue that holds galaxy clusters together will be overwhelmed. Those vast collections of thousands of galaxies will be torn apart, their members flung away from each other into the expanding darkness. Next, the galaxies themselves will be dismantled. The relentless stretching of space will overcome the gravity binding individual galaxies like our Milky Way. Stars will be pulled from their orbits, sent flying away from their galactic centers into the growing void. Our own solar system would still be intact at this point, a tiny island of order in a sea of increasing chaos, but its fate is already sealed. As the acceleration continues to intensify, it will begin to attack smaller and smaller structures. About 60 million years before the end, the expansion force will become stronger than the gravity holding our solar system together. The Sun's grip on the planets will fail. Earth will be ripped from its orbit along with every other planet, becoming isolated worlds hurtling independently through space. The sky would change terrifyingly fast, with the Sun and the other stars receding into darkness as the space between them expands at an ever-increasing rate. In the final months, the force will become so powerful that it will overcome the forces holding individual planets and stars together. Earth itself would be torn apart. The gravitational force holding our planet together would be lost to the expansion. Mountains, rocks, and soil would be pulled away from the planet's core and flung apart. But the true horror reaches its climax in the final moments. Minutes before the end, the stretching of space will exceed the strength of molecular bonds. Every object, every creature, every structure will fly apart as the atomic forces that hold matter together are defeated. In the last unimaginable fraction of a second, the very atoms that make up everything in the universe will be shredded. Atomic nuclei will be torn apart into their constituent protons and neutrons. And then, finally, those subatomic particles themselves will be ripped apart, dissolving into a formless, disconnected sea of fundamental particles unable to ever interact again. The universe would not end with a crash, but with a silent, ultimate disintegration. Reality itself would be dissolved, leaving behind nothing but an infinitely expanding, perfectly empty, and utterly lifeless void, where the very concept of time and distance loses all meaning. The Big Rip is the most personal of apocalypses because it doesn't just destroy the universe around us. It destroys the very fabric of what we are, promising a final, inescapable end to structure, life, and existence itself. But if the Big Rip represents a slow, inexorable unraveling of the cosmos, then the next phenomenon is a sudden, screaming declaration of power from the universe's most voracious engines. We have arrived at number 18, quasar death beams. To call a quasar a mere object is a profound understatement. It is a cosmic cataclysm, a beacon of annihilation so bright it can outshine 1,000 galaxies, and at its heart lies the ultimate predator, a supermassive black hole in the midst of an unimaginable feast. The term quasar is short for quasi-stellar radio source, a name born from their initial mystery. When first discovered, they appeared as faint, star-like points of light, but their spectra revealed something shocking. They were moving away from us at tremendous speeds, meaning they were not stars in our galaxy, but objects of incredible power located in the distant young universe. We now understand a quasar is the intensely bright core of a distant galaxy, and its brilliance comes from one thing only: friction. As enormous quantities of gas, dust, and even entire stars spiral into the supermassive black hole at the galaxy's center, this material doesn't just vanish. It forms a seething, superheated disk of plasma called an accretion disk, swirling at near light speed just outside the event horizon. The friction within this disk heats it to temperatures of millions of degrees, causing it to glow with a blinding light that can be seen across the universe. This process is so efficient at converting mass to energy that it dwarfs the output of nuclear fusion. A quasar can be over 1 trillion times brighter than our Sun. Yet the raw light is not the most fearsome weapon in the quasar's arsenal. That distinction belongs to its jets. Along the black hole's spin axis, perpendicular to the accretion disk, magnetic fields become twisted into unimaginably powerful coils. These fields act like the barrel of a cosmic railgun, channeling and accelerating some of the infalling material not into the hole but away from it. These jets are launched at velocities approaching the speed of light, blasting across intergalactic space for millions of light years. They are not gentle streams, they are focused beams of high-energy particles and radiation, a plasma hellstorm that stretches far beyond the boundaries of their host galaxy, often punching into the space of neighboring galaxies. To stand in the path of one of these jets would be to experience an energy flux beyond comprehension, a continuous blast of X-rays and gamma rays that would strip a planet of its atmosphere and scour its surface to bare rock in a geological instant. This is where the concept of the death beam becomes terrifyingly real. A quasar's jet does not need to score a direct hit on a planet to sterilize it. The radiation and particles flooding out from the beam can create a lethal zone thousands of light years wide. Any planetary system within this cone of destruction would be subjected to a constant, eradicating barrage. Complex molecules necessary for life would be shattered by the radiation. Atmospheres would be ionized and stripped away. The jet represents a form of cosmic censorship on a galactic scale, potentially preventing the rise of life in entire sectors of a galaxy for the millions of years that the quasar remains active. It is the ultimate negative feedback loop. The same black hole that might provide the gravitational anchor for a galaxy to form also possesses the power to render vast swaths of that galaxy completely lifeless. We are fortunate that the supermassive black hole at the center of our own Milky Way, Sagittarius, a star, is currently dormant and not powering a quasar. But we can look out into the universe and see other galaxies where this is not the case, where a central, brilliant point of light serves as a warning of the destructive power slumbering in the heart of most galaxies, a power that could, if stirred from its sleep, fundamentally alter the habitability of our entire cosmic neighborhood. It was the kind of event astronomers dream of, a visitor from a place beyond our imagination. In October 2017, the Pan-STARRS telescope in Hawaii detected a faint speck of light moving against the backdrop of stars. But its trajectory was unlike anything ever seen before. It wasn't orbiting the sun. It was screaming through our solar system at a blistering 57,000 miles per hour on a hyperbolic path, meaning it was not bound by the sun's gravity. This was no comet or asteroid from our own celestial backyard. This was an interstellar traveler, the first ever confirmed object from another star system to pay us a visit. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. and the message it brought was one of profound and unsettling mystery. From the very beginning, Oumuamua refused to fit into any neat category. As telescopes around the world swiveled to track its rapid departure, they gathered data that only deepened the puzzle. The first shock was its shape. By measuring how its brightness changed dramatically over a period of hours, scientists deduced that it was not a roughly spherical object. Instead, it was highly elongated, tumbling end over end like a thrown bottle. Estimates suggested it was perhaps 10 times longer than it was wide, a cigar or a pancake shape unlike any natural object we've seen in our solar system. This was bizarre. While we have asteroids that are somewhat elongated, nothing comes close to that extreme ratio. The processes that form objects in space, collisions, gravitational accretion, tend to make them more rounded. Oumuamua's shape was a flagrant violation of cosmic norms. Then came the real head-scratcher, as Oumuamua slingshotted around the Sun and began its journey back out into interstellar space. Astronomers meticulously tracked its path. They expected its speed to be governed solely by gravity, but it wasn't. The object was accelerating, speeding up in a way that gravity alone could not explain. For a comet, this is common behavior. As a comet approaches the Sun, its icy surface heats up, causing it to vent gas and dust in a process called outgassing. This acts like a natural rocket engine, providing a non-gravitational push. So, scientists immediately looked for this telltale sign, a coma or a tail of material surrounding Oumuamua. They pointed every instrument they had at it, and they found nothing. No gas, no dust, no cloud of particles, no visible evidence of outgassing whatsoever. Yet somehow it was accelerating. It was as if an invisible engine was giving it a gentle but persistent push. The scientific community was electrified and deeply divided. How do you explain an object that acts like a comet but doesn't look or behave like any comet we've ever seen? Natural explanations were vigorously proposed. Perhaps it was a shard of a planet that was torn apart by its star's gravity, giving it that strange shape. Maybe it was a fractal-like aggregate of dust, like a cosmic dust bunny. The most popular theory suggested it could be a chunk of solid hydrogen ice. A hydrogen iceberg would not leave a visible trail of dust, and as it warmed near the Sun, the sublimating hydrogen gas could provide the necessary thrust without being easily detectable. But there's a problem with that. A hydrogen iceberg would evaporate rapidly in the heat of interstellar space, making its journey to our solar system nearly impossible. Other scientists proposed it was a chunk of solid nitrogen ice, similar to what is found on Pluto's surface. When scratched, each theory seemed to have a fatal flaw. This failure of conventional models to provide a satisfying answer is what opened the door to a more speculative and, for many, more terrifying possibility. Could Oumuamua be artificial? The most prominent proponent of this idea was Harvard astronomer Avi Loeb, who argued that we must consider the possibility that it was a piece of advanced alien technology. The most captivating hypothesis was that Oumuamua could be a light sail, a vast, thin sheet of material designed to be pushed by the radiation pressure from starlight. This would perfectly explain its unusual acceleration without the need for visible outgassing. Its tumbling motion could be explained if it was a derelict craft, no longer under control, wandering the galaxy like a ghost ship. Its flattened, pancake-like shape would be ideal for a light sail. Loeb's suggestion, detailed in his book Extraterrestrial, was met with intense skepticism from much of the scientific community, who accused him of sensationalism. But his fundamental point was valid. When a natural explanation consistently falls short, it is not unscientific to at least consider an artificial origin. The very fact that we had to have the debate at all is what makes Oumuamua so deeply unsettling. The ultimate terror of Oumuamua is not that it might have been an alien probe, that we will never know for sure. By the time we realized how strange it was already too far away, too faint to observe further. it has vanished back into the depths from which it came, taking its secrets with it. It was a once-in-a-lifetime event that passed through our neighborhood without a word, a cosmic glimpse of something so strange it defies all our categories. It serves as a humbling reminder that the universe is capable of producing phenomena we have not even begun to imagine. Whether it was an exotic nitrogen iceberg or a discarded piece of a long-dead civilization, Oumuamua is a permanent anomaly. It is a single data point that screams that we know far less than we think we do, and that the great vastness between the stars may not be as empty as we assume, but could be filled with strange and silent travelers, most of which we are utterly blind to. While we grapple with the mysteries of interstellar visitors and the vast forces shaping the cosmos, the most certain and personally terrifying fate we face is not from a distant anomaly, but from the very heart of our own solar system. The Sun, the giver of life, has a death sentence written into its core, and in carrying it out, it will irrevocably destroy the inner solar system. This is the destiny of a red giant, the 20th terrifying phenomenon on our list, and it is the one apocalypse we know for sure is coming. Our Sun is a titan of stability, a main sequence star that has burned consistently for over 4.5 billion years. This stability is born of a perfect, delicate balance between the outward push of nuclear fusion in its core and the inward crush of its own immense gravity. But this balance is temporary. The fuel for this fusion hydrogen is finite. In about 5 billion years, the Sun will exhaust the hydrogen in its core. With the central fusion engine sputtering, the balance will break. Gravity, now unopposed, will begin to crush the core inward, causing it to heat up to even more extreme temperatures. This new heat will push the Sun's outer layers outward with tremendous force, initiating a dramatic and violent transformation. The Sun will begin to swell. It will not be a slow growth, but a monstrous inflation. Over the course of several 100 million years, it will expand to a diameter hundreds of times its current size. Its outer layers will cool as they expand, shifting its light from a brilliant white-yellow to an ominous, hellish red. This is the red giant phase. In this new form, the Sun will not just be larger, it will be an utterly different entity, a bloated behemoth that will dominate the sky and rewrite the rules of our solar system. Its outer atmosphere will become tenuous and wispy, but its radial reach will be immense, stretching out to engulf the orbits of the inner planets. Mercury, the closest planet, will be the first to go. It will be swallowed whole, vaporized almost instantly as it spirals into the diffuse but superheated outer layers of the star. Venus will follow soon after, suffering the same fate, its thick atmosphere offering no protection against the stellar inferno. Then the Sun's growing sphere will approach Earth's orbit. For a time, there is a grim astronomical debate about our planet's ultimate fate. Some models suggest the expanding Sun will lose a significant amount of mass through powerful stellar winds in its old age. This mass loss would weaken its gravitational grip, potentially allowing Earth's orbit to migrate outward, just enough to avoid being physically engulfed. But this potential escape is a hollow victory. It merely exchanges one hell for another. Long before the Sun's surface reaches Earth, our world will have become utterly uninhabitable. As the Sun grows larger and brighter, the increase in solar radiation hitting our planet will be catastrophic. The first stages will be an extreme amplification of our current climate change fears. The oceans will begin to heat up, their vast thermal capacity delaying the inevitable but not preventing it. Over millions of years, the temperature will climb beyond anything life can withstand. The polar ice caps will vanish. The oceans will start to boil, not just in small patches but globally. The entire surface of the planet will become a scalding pressure cooker. The water vapor, a potent greenhouse gas, will flood the atmosphere, trapping even more heat and accelerating the boiling process in a runaway feedback loop of utter devastation. The atmosphere itself, stripped away by the intense heat and the punishing pressure of the solar wind from the now massively enlarged Sun, will be eroded into space. Earth will be left a barren, molten lava rock, its surface scorched and scoured, silhouetted against the monstrous red disk that fills half the sky. This violent expansion is merely the prelude to the Sun's final act. After a relatively brief period as a red giant, perhaps only a billion years, the core will become hot and dense enough to begin fusing helium into carbon and oxygen. This process is unstable, and the Sun will begin to pulse violently, shedding its outer layers in a series of immense, beautiful, and deadly convulsions. These expelled layers will form a vast, expanding cloud of incandescent gas, a planetary nebula. This glowing shroud will light up the interstellar neighborhood for tens of thousands of years, a fleeting funeral shroud for a star. All that will remain of our Sun is its exposed, incredibly hot core, now a white dwarf. This Earth-sized ember of carbon and oxygen will be all that's left, a dense, fading cinder that will slowly cool over trillions of years, a diamond in the dark marking the grave of a solar system. The red giant phase is the ultimate reminder that the universe is a place of constant, violent change, and that even the most fundamental sources of stability in our lives are temporary. Our star's lifespan, which seems immeasurably long to us, is but a brief flash in the cosmic timeline, and its death is a predetermined event that will erase every trace of our world, a solemn testament to the fact that nothing in the cosmos is built to last forever. But even the Sun's eventual death pales in comparison to a chill that permeates the very fabric of the cosmos, a frozen fingerprint from the dawn of time that holds a secret we are only just beginning to decipher. This brings us to our 21st terrifying phenomenon, a ghost in the machine of creation known as the cosmic microwave background cold spot. To understand why this anomaly is so deeply unsettling, we must first journey back to the very beginning of everything. The cosmic microwave background, or CMB, is the oldest light in the universe. It is the faint thermal radiation that fills all of space, the cooled remnant of the first rays that streamed forth when the universe became transparent about 380,000 years after the Big Bang. Think of it as the universe's baby picture, a snapshot of its infancy. For cosmologists, this radiation is a treasure trove of information. It is incredibly uniform, but not perfectly so. Tiny fluctuations in its temperature on the order of millionths of a degree map the seeds of all future structure, the slight over-densities of matter that would one day gravitationally collapse to form galaxies, stars, and us. This map is mostly a gentle, random-looking tapestry of warm and cool patches, consistent with our models of cosmic inflation. But then there is the spot. In the constellation of Eridanus, there exists a region of the CMB that is profoundly, shockingly cold. This isn't a minor variation. It is a massive anomaly, a void in the ancient radiation nearly a billion light-years across that is significantly cooler than the surrounding space. Its existence was confirmed by multiple spacecraft, including NASA's Wilkinson Microwave Anisotropy Probe and the Planck satellite, and it defies easy explanation. The scale of this cold spot is the true source of the terror. It is so vast that it should not exist according to the standard model of cosmology. The laws of physics, as we understand them, place a limit on how large such a structure can be, a concept rooted in the speed of light and the age of the universe. The cold spot smashes through that limit. Scientists have proposed two primary explanations, and both are mind-bending in their implications. The first and more conventional theory is that we are looking at a truly enormous void, a supervoid of staggering proportions. The CMB radiation loses a tiny amount of energy when it passes through a region of space that is less dense than average, a phenomenon known as the integrated Sachs-Wolf effect. If this cold spot is caused by a void, it would have to be the largest structure ever discovered, a near-empty region of space so colossal it would contain far fewer galaxies and galaxy clusters than any other part of the known universe. The mere existence of such a void would force a dramatic rewrite of our understanding of how matter clumped together in the early universe, challenging the very foundation of modern cosmology. However, the second and far more radical explanation is the one that truly sends a shiver down the spine. Some cosmologists propose that the cold spot is not a feature of our universe at all, but rather a bruise, a scar from a collision with another universe. This idea emerges from the theory of the multiverse and eternal inflation, which suggests our universe is just one expanding bubble in a frothing, infinite sea of other bubble universes, each with its own potentially different laws of physics. In this model, if another universe bubble had collided with ours in the distant past, the energy released at the boundary of that collision could have left an imprint on our CMB, a circular region where the background radiation was drained of energy, creating a cold spot. If this is true, then the cold spot is the first empirical evidence, however tentative, that our universe is not alone. It is a crack in the door to the multiverse, a tangible sign that we are part of a reality far grander and more bizarre than we ever imagined. The profound terror of the cold spot lies in this duality. It is either a cosmic structure so large it breaks our understanding of the universe's evolution, suggesting a fundamental flaw in our most cherished theories, or it is a window into an entirely new ontological reality, proof that our cosmos is just one island in an infinite archipelago of universes. Either possibility is humbling. Either we are wrong about the basic rules governing existence, or we are not the only existence there is. This cold, silent patch on the map of creation is a permanent question mark, a reminder that even our most complete picture of the cosmos is still missing crucial pieces, and that the answers, when they come, may be more shocking than any fiction we could devise. But if the cold spot is a relic of cosmic origins, a silent and ancient anomaly, then the next phenomenon is a sudden, violent, and screaming event happening in the present day, a catastrophic explosion born from the universe's most unstable object. We now arrive at number 22, and it is a force of nature so powerful it can reach across light years of empty space to punch a planet in its face, the magnetar starquake. To understand the sheer terror of this event, you must first meet the magnetar. We've already discussed neutron stars, the city-sized remnants of supernovae so dense that a teaspoon of their material weighs 1 billion tons. A magnetar is a neutron star that has drawn the cosmic short straw in the most dramatic way possible. It is a neutron star that, during its violent birth, had its internal magnetic field wound up, twisted, and amplified to levels that defy all reason. The magnetic field of a typical magnetar is 1,000 trillion times more powerful than Earth's. To put that in perspective, if a magnetar were located halfway between Earth and the Moon, about 240,000 miles away, its magnetic field would be strong enough to strip the information from every credit card on the planet. But that's just a parlor trick. The real danger is what happens when this unimaginable force is suddenly and violently released. A neutron star's surface isn't a smooth, solid ball. It's a crust of immensely dense, iron-like material, perhaps 1 mile thick, floating on a superfluid core of neutrons. This crust is under unbelievable strain, crushed by gravity and torqued by the insane magnetic field frozen within the star. Over centuries, the magnetic field stresses the crust, bending and warping it like a metal plate under immense pressure. Eventually, the strain becomes too much. The crust can no longer hold its shape. It suddenly cracks and shifts a starquake. This isn't like an earthquake on Earth, which releases pent-up energy from tectonic plates grinding together. This is a magnetic cataclysm. When the crust fractures, it releases the energy of the magnetic field itself in a single, apocalyptic snap. The numbers involved are so large they become meaningless abstractions. In a tenth of a second less time than it takes to blink, a single magnetar starquake can release more energy than our Sun will emit over the next 100,000 years. The event is so energetic it can briefly outshine every star in our entire galaxy combined. This energy isn't released as a gentle glow. It is a focused storm of high-energy radiation, a blast of X-rays and gamma rays that screams into the void. It is one of the most luminous events known to occur in the universe. The true cosmic horror of a magnetar starquake is its reach. A typical supernova has to be relatively close to threaten Earth within maybe 50 light-years. But the lethal radiation from a magnetar's crustal snap can sterilize planets from a distance of several light-years, and its electromagnetic pulse could disrupt or fry the electronics on any spacecraft or planet within a staggering 10 light-years. To have your world's atmosphere stripped away or your civilization's technology sent back to the Stone Age by an event that happened a decade ago in a star system you've never even heard of is a terrifying prospect. We are fortunate that the known magnetars in our galaxy are all at a safe distance, but the universe is a violent place, and the discovery of a closer one would instantly put it at the top of any existential threat list. The magnetar starquake is the ultimate example of a cosmic short fuse, a reminder that stability is an illusion, and that some of the universe's most destructive events are not the slow burn of stellar evolution, but the sudden, explosive failure of a structure pushed far beyond its breaking point. Yet for all the terrifyingly destructive power of magnetars and the strange silence that defines our universe, one of the most profoundly unsettling ideas isn't about a force of nature, but a theory of behavior. It is a solution to the Fermi paradox so chilling in its logic that it reframes our entire search for cosmic company not as a hopeful endeavor, but as a potentially fatal mistake. This is the dark forest solution, and it proposes that the universe is not a bright, welcoming community, but a vast, dark, and ancient woodland where every civilization is a hunter, armed and hidden, terrified of revealing its location. The theory, popularized by author Lou Sixin in his science fiction series but rooted in grim cosmological logic, begins with a few simple, almost indisputable premises. First, the primary goal of any civilization, like any species, is survival. Second, resources in the universe, while vast, are ultimately finite. And third, there is no way to know the true intentions of another civilization, especially one that might be vastly more advanced. The gap between stars makes communication slow and trust impossible to build over such immense distances. You could never be sure if a message you received was a genuine hello or a sophisticated lure. From these axioms, a terrifyingly rational strategy emerges. In a dark forest, if you hear a rustle in the leaves, you don't call out a friendly greeting. You assume it is a threat, you stay perfectly silent, you aim your weapon, and you prepare to shoot first. Announcing your presence is not an act of friendship, it is the height of naivety. A civilization that broadcasts its location is essentially shouting in the woods, making itself a target for any other hunter who has already learned the paramount rule of survival: strike before you are struck. The safest, most logical course of action for any species that wishes to endure is to become a perfect predator, to listen intently with every technological means available, but to make absolutely no sound of its own. Any civilization you detect, even one that seems primitive, must be considered a potential existential threat. Given enough time, a primitive civilization could experience a technological singularity and surpass you, becoming the hunter that ends your existence. Therefore, the only guaranteed path to long-term survival is to quietly and efficiently eliminate any other life you find before it has the chance to do the same to you. This model transforms the great silence of space from a mystery into a grim inevitability. The galaxy isn't empty, it is likely teeming with life, but it is a life that has perfected the art of staying hidden. They are all listening and they are all ready to fire. Our own attempts at communication, from the Arecibo message beamed to a star cluster in 1974 to the continuous radio and television signals leaking from our planet for the last century, could then be seen not as a hopeful reaching out but as a catastrophic error. In the dark forest, we haven't been waving a friendly hello. We have been starting a campfire, singing loudly, and completely unaware of the countless eyes now watching us from the darkness, their fingers resting on the trigger. The eerie quiet we perceive is not an absence of life, but the silence of a standoff between civilizations too terrified to make a move, a galactic Mexican standoff lasting for millions of years. It suggests that the ultimate goal of intelligence is not to explore and connect, but to survive by any means necessary, even if that means spending eternity in hiding, forever afraid of the light. But if the dark forest presents a universe of hidden predators, then our next terrifying concept turns the lens inward, to the very nature of our own consciousness and its relationship with reality itself. This brings us to a theory so bizarre it merges the coldest equations of quantum mechanics with the most primal human fear of mortality, only to arrive at a fate that is, in its own way, a form of eternal torment. We are talking about the 24th terrifying phenomenon, quantum immortality. To grasp this idea, we must first venture into the strange world of quantum mechanics, specifically the many worlds interpretation. In the classic quantum thought experiment, Schrödinger's cat, a feline is placed in a box with a radioactive atom, a Geiger counter, a hammer, and a vial of poison. If the atom decays, it triggers the counter, which releases the hammer, which shatters the vial, killing the cat. According to quantum rules, until the box is opened and observed, the atom exists in a superposition. It has both decayed and not decayed. Therefore, the cat is both alive and dead, a blur of conflicting possibilities. The standard Copenhagen interpretation says this superposition collapses into one reality when observed. But the many worlds interpretation proposed by physicist Hugh Everett argues something far more radical. It says the superposition never collapses. Instead, the universe literally splits in two. In one universe, the atom decayed and the cat is dead. In another, perfectly real branch of reality, the atom did not decay and the cat is alive and well. Every single quantum event, and there are trillions every second, potentially causes the universe to bifurcate, creating a constantly flowering multiverse of every possible outcome. Now apply this to human consciousness and the experience of death. Imagine you are in a situation with a very high probability of death. Perhaps you are in a plane that is crashing. From a macroscopic perspective, the odds of survival are nearly zero. But according to many worlds, there must exist a branch of the multiverse, however improbable, where a near-miraculous sequence of quantum events occurs to allow your survival. Maybe a sudden gust of wind cushions the impact just enough, or a structural flaw somehow holds. In the vast majority of branching universes, you die. But in one very, very thin branch, you live. The theory of quantum immortality suggests that your conscious experience is tied to the branches of the multiverse in which you continue to exist. You are never able to experience your own death because, from your first-person perspective, you will always find yourself in a timeline where you survived. This sounds like a promise of eternal life, but it is actually a recipe for a cosmic horror story. It doesn't mean you live forever in good health. It simply means you never experience the cessation of consciousness. You might survive the plane crash but be horribly mangled and burned. You would then continue to exist in that timeline. Later, you might contract a terminal illness. Again, in most branches you succumb, but in one branch an unexpected remission or an experimental treatment works. You survive, but perhaps in immense pain or with severe disability. This process continues indefinitely. You would be forced to experience every possible catastrophe that doesn't result in instant, total annihilation. You could live through a global nuclear war, a pandemic that ravages your body, or the slow heat death of the universe, always finding yourself in the one timeline where you cling to a flicker of life. Your life would become a relentless series of narrowly avoided deaths, each one leaving you more broken than the last, a testament to the unthinking, mechanical branching of reality that is completely indifferent to your suffering. You wouldn't be immortal, you would be a prisoner of probability, cursed to always be the version of you that didn't die, no matter how much you might wish for it. The true terror of quantum immortality is its profound isolation. Everyone you know and love would, in your branching timeline, eventually die. You would watch them all go while you remain, your continued existence not a triumph but a statistical anomaly. The world around you would become increasingly strange and unrecognizable as you outlive your species, your planet, and even your star. You would be the ultimate observer, a conscious fossil trapped in a reality that has moved on, forever alone in a multiverse that has an infinite number of graves with your name on them, yet never allows you to lie down in one. It is a theory that trades the fear of oblivion for the dread of an endless, inescapable existence, suggesting that the universe's ultimate joke might be that death is not an event we experience, but a destination we forever avoid. Yet after eons of branching realities and cosmic standoffs, after quasars and magnetars and wandering stars, the universe itself is not a permanent stage. Every phenomenon we have explored, from the most violent explosion to the most profound silence, is merely a temporary event in a grand cosmic story that has a final, definitive, and utterly inescapable last page. This brings us to the ultimate conclusion, the 25th and most profoundly terrifying phenomenon on our list, a fate so absolute it renders all others trivial, the heat death of the universe. This is not an explosion or a collapse, but a slow, eternal, and irreversible fading into nothingness, the final victory of chaos over order. To understand this end, we must understand its architect, entropy. In simple terms, entropy is a measure of disorder, a universal principle that states that all systems, from a cup of coffee to a galaxy, naturally progress from a state of order to a state of disorder. Heat energy flows from hot objects to cold ones, never the other way around, inevitably evening out temperatures. It's why a dropped egg splatters but never reassembles itself, why ice melts in a warm room, and why our sun is constantly burning its fuel. This one-way street is the arrow of time itself. The universe began in a state of incredibly low entropy, the hot, dense, and perfectly ordered singularity of the Big Bang. Ever since, it has been relentlessly evolving toward a state of maximum entropy, spreading its energy thin across an ever-expanding volume. The heat death is the point where this process reaches its logical, chilling conclusion. It begins with the stars, one by one, across trillions of years. Every star in the universe will exhaust its nuclear fuel. The massive ones will die in supernova, while stars like our sun will shed their outer layers and fade into white dwarfs. These stellar embers will then slowly cool over incomprehensible timescales, eventually becoming black dwarfs, cold, dark spheres of crystallized carbon, invisible against the blackness of space. The last red dwarfs, the smallest and most frugal stars, will be the final beacons, clinging to fusion for perhaps 10 trillion years. But eventually, even their faint light will flicker and die. Next, the galaxies themselves will unravel. The same dark energy that may one day cause a big rip will, in this more likely scenario, continue to accelerate the universe's expansion. Galaxies will be pushed apart until each is an isolated island, its stars too far apart to see with the naked eye from any other. Within these galaxies, the gravitational dance will slowly decay. Stars will be flung from their orbits or will spiral into the central supermassive black holes through a process called dynamical friction. Over an almost endless epoch, these black holes will be the last structures of any significance, growing fat on the remains of their galaxies. But even black holes are not eternal. Through a remarkable quantum process at their event horizons predicted by Stephen Hawking, they slowly evaporate, emitting a faint trickle of radiation now known as Hawking radiation. For a stellar mass black hole, this process takes longer than the current age of the universe. For a supermassive one, it could take a googol years, a 1 followed by 100 zeros. But given enough time, even the largest black hole will radiate away its mass, fading out of existence in a final, silent pop, and then there will be nothing. The universe will have reached a state of maximum entropy. All energy will be evenly distributed across an infinite and ever-expanding void. There will be no hot spots and no cold spots. Every point in space will be the same infinitesimal temperature, just a fraction of a degree above absolute zero. With no energy differences, no gradients, no hot or cold, work becomes impossible. The universe will have no usable energy left. Time, as we understand it, will cease to have any meaning, for without change there can be no past, present, or future. It will be a state of infinite, perpetual, and perfect equilibrium, a timeless, featureless, silent, and utterly dark nothingness. It is the true end of everything, not with a bang, but with the faintest, coldest whisper imaginable, a whisper that then echoes in a void forever, with no one and nothing left to hear it. The profound terror of the heat death is its absolute finality and its stark indifference. It is not an act of destruction. It is simply the universe falling asleep and never waking up. Every achievement of every civilization, every work of art, every moment of love and loss, every star ever born, every planet that ever hosted life, all of it will be erased not by violence, but by the relentless and impersonal ticking of a cosmic clock winding down. It is the ultimate guarantee that nothing lasts forever, that all structure is temporary, and that the cosmos, for all its present fury and brilliance, is ultimately destined for a silence and a darkness so complete that the very concepts of existence and meaning will themselves become forgotten relics of a forgotten age. In the face of such a fate, our struggles and wonders are both magnified in their fleeting beauty and humbled by their ultimate insignificance, a poignant reminder to cherish the light and the heat while they still last. From the silent, drifting hunters of rogue black holes to the ultimate cosmic silence of heat death, our journey through these 25 terrors has revealed a universe of breathtaking beauty and profound brutality. We've witnessed galaxies consumed in slow-motion feasts, felt the chilling pull of dark flow from beyond the edge of reality, and trembled at the thought of vacuum decay rewriting the laws of existence in an instant. We've stood in awe of stellar zombies detonating with the light of billion suns, contemplated the eerie silence of the Fermi paradox, and imagined the lonely fate of rogue planets sailing through the eternal night. Each phenomenon, from the crushing magnetic fury of magnetars to the mysterious passage of Oumuamua, serves as a powerful reminder that the cosmos operates on a scale of power and time that dwarfs human comprehension. These are not just abstract scientific concepts, they are the real forces shaping the vast theater in which our entire existence is merely a fleeting, momentary flash. Contemplating these cosmic horrors inevitably shifts our perspective on our own place in the grand scheme. In the face of gamma-ray bursts that can sterilize entire sectors of a galaxy, or solar superflares that could undo centuries of technological progress overnight, our daily worries and earthly conflicts can seem almost trivial. We are living on a fragile, pale blue dot orbiting an average star in a quiet suburb of a galaxy that is itself being pulled toward an unseen great attractor, all while the very fabric of space is stretching apart at an accelerating rate. This realization is not meant to diminish our significance, but to expand our awe. The fact that we fragile beings, made of stardust forged in the heart of long-dead stars, can even comprehend these immense and terrifying wonders is a testament to human curiosity and resilience. We are the universe becoming conscious of itself, capable of looking into the infinite dark and not only feeling fear, but also pursuing understanding. Now, we want to hear from you. Which of these 25 cosmic terrors sent the biggest shiver down your spine? Was it the patient, inevitable expansion of a red giant that will one day consume our world, or the silent, statistical dread of quantum immortality? Perhaps the stealthy approach of a rogue black hole or the ominous silence of the dark forest hypothesis left you contemplating the night sky with a new sense of unease. Share your thoughts and the one that haunts your imagination the most in the comments below. We love reading about what captures your curiosity and sparks your wonder. If your mind is reeling from these revelations about our beautiful and terrifying universe, you're in the right place. We are dedicated to exploring the deepest mysteries and the most mind-expanding concepts, from the edges of astrophysics to the frontiers of theoretical science. For more journeys into the unknown, make sure to subscribe and hit the notification bell so you never miss an exploration. Thank you for joining us on this incredible voyage through the cosmos. We look forward to seeing you in the next video.